So as we know, when we are considering this particular syllabus, so we are just concentrating on the unit number 1. Okay, sir has already shared with you whatever the important textbooks and the reference books and the e-sources are there regarding the NPTEL. So definitely I will also share that particular the entire presentation for the unit number 1. So likewise for all the unit once we finish that particular the unit. Okay, so when we are considering this particular the machining process, so as we know what exactly the machining means, okay, and what this machining process is differed from the other forming processes. Okay, so we know basically what exactly the machining means. Okay, so normally whatever the kinds of the this by unwanted material which is to be removed with the help of the chips, so we convert the raw material into the finished product. That is what we can simply define the machining means. And thereof, there are the number of applications of this the metal cutting processes. Okay, so as we know why machining is important, we already know that whatever the variety of the applications are there, so in which the forming processes are definitely there, but apart from that the machining process plays an important role, such as the thread cutting is there or gear cutting is there, and so many different kinds of the processes which are there. Okay, so why machining is important? Variety of the work material can be machined. Most frequently it is applied to metals. Okay, and that is what is the, we can say that the area where we can consider the material category. Then apart from that also variety of the part shapes and the geometry and the different features such as possible. Just I have mentioned earlier that the thread cutting is there, or the gear manufacturing process is there, or whatever the kind of the exactly we want to drill the hole. Okay, or when we want to perform the any kind of the operation on the edges as well as on the surfaces, and we are getting good and excellent surface finish and excellent dimensional accuracy. That's why we are preparing this particular the machining is an important process. So similarly, there are some of the disadvantages are also there. As we know, whatever the unwanted material is removed in the form of the chips. Okay, so whatever that particular the chips which is there, so that we can consider as a waste material. But again, if we collect that particular the chips for a particular type of the metal, and then metal or alloy respectively, if we consider that particular the entire chips which is to be generated, and if we store it, and again if we send it, if we segregate separately, then it will definitely again help in the what we can call it as a in the making of the material. But some kind of the material that is definitely is there, that we can call it as a waste. And also when we are considering the different kinds of the processes under the cutting also, so it will take time, means the time consuming processes are also there. If we perform the manually, definitely the time consuming is there. But if we select the particular kind of the semi-automatic or the automatic machine, so definitely the time consumed or the time which is to be required for the complete conversion from the raw material to the finished product, so that will again we can say minimize the time duration. These are the two important kind of the drawbacks normally which we can observe. Then apart from that also what exactly the sequence of the manufacturing processes or the machining is to be there. So normally, as we know, such as the casting is the one of the process, then forging is there, bar drawing is there. So we already learned this particular the processes in second year. Okay, so what happened when we are considering this particular the metal cutting process? Okay, so in that whatever the important elements which are there, we must know. Okay, so work material is there, then cutting tools are there, then machine tools are there, then what exactly the machining conditions are there. So by with the help of all this, we are in a position to produce the semi-finished or the finished product. My screen is visible to everyone?
Yes, sir.
Okay, Thank you. So
Yes,
this
sir.
is what we okay, thank you. So as we know, this is what is the simple diagram that gives us an idea what are the important elements, or we can say that for which the metal cutting process which we can consider. Normally, as we know, surely the sir has already discussed about the material removal processes. So in for this particular your third year, so we have to consider only the material removal processes in elective one, which is shown in this particular the flow chart. If we consider this particular the flow chart, so in that whatever the metal removal processes are there, so that are categorized into two main categories. Traditional category is also there, and the advanced metal removal processes are also there. So that is not shown in this particular the flow chart. So just we are considering here the traditional processes, metal removal processes. So in that there are again the categorization in the traditional metal removal processes into two ways. One is the cutting processes, and second categorization is based on the finishing processes. Okay, so whenever we want to remove the unwanted, yes, any problem? Any problem to anybody? Yes, Manoj, I'm audible.
Yes, sir.
Okay, so screen is visible.
Yes, sir.
Okay, okay, thank you. So as we know, when we are considering this particular the cutting process, so in that whatever the kind of the workpiece material which is supposed to be there, so that we can consider normally in the shape circular shape. Okay, and apart from that also there are the different kinds of the shapes which are there. So for that the second category which is to be there. Now, when we are considering the circular shapes, okay, so for that circular shape, when we want to perform the cutting operation, so there is a turning process is there, boring process is there, then drilling processes are definitely there. Okay, when we consider normally the shape which is different than the circular shape, so normally milling is the operation, okay, which is used to convert into the required shape. Planning is there, planing is there, shaping is there, gear cutting, and the broaching is also there. Okay, so these are the different kinds of the processes when we consider the circular shape and the other kind of the shapes under the cutting, under the traditional metal removal processes. So far as the finishing processes are there, again these are categorized into the two processes. Bonded abrasives are there and the loose abrasives are there. Okay, so whatever the finishing operations which are coming under the category of the traditional metal removal processes, so we may use the bonded abrasive or and loose abrasive also. When we are considering the bonded abrasive, so definitely the grinding, honing, coated abrasives are there, and the loose abrasives, so in that the lapping and polishing which is to be there. So this is already we know when we are considering this particular the metal removal processes. Okay, so normally what happens when we are considering the metal cutting operation, so such kind of the phenomena or such kind of the entire arrangement which is to be there. So I will let you explain this particular the phenomena when we discuss more about when the actual chip formation process which is to be there. So this is what exactly the figure 21.2 A and B. So that gives us an idea about the figure A shows the cross-sectional view of the machining process. Figure B shows the tool with the negative rake angle and whatever the positions which is to be compare of with the positive rake angle in as far as the figure A is concerned. So normally, as we know, whenever we are going to consider the whatever the elements of the machining process, okay. So just suppose we are considering one of the example of the turning operation. I think most of the DSC students know that they have already performed some operations on the lathe machines, and those students who are supposed to be there and they might have submitted their jobs also. Okay, So normally what happens when we are considering this machining process? Okay. So what happen exactly, what kind of the elements which are involved, and what exactly the kind of the terminology which is to be there. Okay. So normally when just we consider an example of the simple machining operation, that is known as a turning operation. If we consider the figure A and figure 1.1, so both the figures are give the same kind of the elements which are involved in the entire process of the machine. So definitely the workpiece is there, then tool is there, then machine is there, and whatever that speed, feed, depth of cut, and then all the important points again related to the tool life which is there. So normally when we consider this the machining process, so there are the requirements which are there. So as we know, definitely the blank we can consider as a workpiece material. So machine which is to be required, then the if the irregular shape or the different kinds of the shape which is to be there, so definitely the fixture which is to be there. So do you have any idea about what is exactly meaning of the friction fixture? Anyone can just discuss, or what exactly the fixture means?
Yeah,
Can you?
sir,
Yes.
work picture is used to hold the workpiece.
Yes.
वर्कपीसला फर्मली होल्ड करण्यासाठी पिक्चरचा यूज
Yes, 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 correct, Suraj. So as we know, when suppose we are performing on the lathe machine, and if the simple job is there, then we can easily place that particular the job inside the job, whatever the 2-jaw or the 3-jaw chuck which is to be there, and with the help of the chuck key, we are closing that, and we are holding the blank into the that particular the machine. But if the irregular shape is there, other than the circular, so for that particular case we need some kind of the some kind of the design of the part, so that will hold that particular the part. Okay, so that is nothing but an fixture. So fixture is used to hold the workpiece material in a proper way, so that there will be the proper kind of the machining which is to be there. Now, when we are considering this particular the machining process requirements, so definitely workpiece is there, machine is there, fixture is there, then power requirement is there, then tools requirement is there, then environment, as we know, speed, feed, depth of cut which is to be there, and whatever the when we are considering this particular the figure number 1.1, so in that we are considering the machining operation. So that is the machining operation is the what we can call it as a turning is the machining process. Okay, so when all these are the things together, so once we start the machining process, that is the turning, then we are in a position to produce. First is the semi-finished product, then the final finished product. Okay, so once the product is as per our requirement, then it is we can consider that the final finished product. After the analysis, or after the what we can call it as a after the supervision, or after the inspection, particularly any kind of the say the surface quality which is not as per the requirement, then after the analysis we are performing suppose the finishing operation, then this entire loop gets closed. So whatever the correction is suppose is required, so it will be given to the tools. Means if it is the manual operation is there, so operator is used to perform that particular the finishing operation. Okay, so these are the what we can say that the requirement for the machining process when we are considering the any kind of the operation. Okay, so as we know, when we are considering the machining entire machining process, so basic elements we must know. So workpiece requirement is definitely there. Without the workpiece, it is not possible the any kind of the tool or the machine to perform the machining operation. So workpiece is definitely an important part. Apart from that is the tool is there, and the next one is the chip formation which is to be there. So as we know, definitely when we start the machining process, so there is and the relative motion between the tool and the workpiece. Okay, unless and until there is and the relative motion between the tool and the workpiece is not there, it is not possible to remove the unwanted material from that particular the raw material or the blank. Okay. So as we know, the unwanted material is removed from the workpiece by cutting action by using the tool. And when we are providing the feed, so the unwanted workpiece material, material is removed from the workpiece. Okay. So already we know that the chips which are formed in a different category. We know that there are the continuous type of the chips are there, discontinuous or the segmental type of the chips are there, then continuous chips are also there, then continuous chip with the built-up age, that is what is there. We will discuss this one by one. As we know, this is definitely the part which is an important one, as we are considering this particular the unit number 1. Now, as we know, normally when we are considering these different elements in the machining process, so definitely the geometry of the single point cutting tool or the multi-point cutting tool plays an important role. Apart from that, also what kind of the category of the workpiece material which is to be there, okay, and what about the speed, feed, depth of cut, and the tool material, okay, so that plays an the important role. As sir has already discussed more about this particular the elements, so we know that how the different kinds of the chips which are formed. So we'll discuss this one by one. So just I will show you one video clip regarding the how the entire machining process which is to be there. So please wait for a while so that I will show that video clip to you. Okay, please wait. I think my screen is visible to everyone right now.
Yes, sir.
Okay. So it is full screen is there on your screen, mobile screen or the laptop screen. It is visible to everyone.
Yes.
Okay. Now, just to understand how exactly different machining elements which are there, okay, and how the cutting action that is taking place. So, just I want to show you where is the position of the workpiece material or the blank, where is the position of the tool. So that definitely as you know from as you already studied that particular the part in the second year, as well as those diploma students, so definitely they have performed the experimentation on the lathe machine also. So please, for all the members, those who are are not familiar with the exactly the what are the different elements in the cutting process, so please observe this video carefully. So definitely it will help to understand and to learn how these the chips which is to be removed. Okay, so please wait.
Centers. In order to take my girlfriend out for a nice dinner, I had to make some money. So that's why I started.
Turning is the most common type of operation of removing the excess material from the workpiece to produce a cylindrical surface to the desired length. The job is held between the center, or a chuck, and rotates at a required speed. The tool moves in a longitudinal direction to give the feed towards the headstock, with proper depth of cut. The surface finish produced by this operation is very good. There are different turning operations can be done. They are straight turning. In this operation, the workpiece is held on the chuck and it is made to rotate about the axis, and the tool is fed parallel to the lathe axis. The straight turning produces a cylindrical surface by removing excess metal from the workpiece. Rough turning. It is the process of removal of excess material from the workpiece in minimum time by applying high rate feed and heavy depth of cut. lathe machine operations on a lathe. The lathe machine operations on a lathe.
So as you know, whenever we want to perform any kind of the machining operation, so as we just seen in that video, that what exactly the kind of the tool which is to be there, and how depending upon what kind of that particular the operation we want to carry out. So according to that, the feed is given to the tool. So we know that what exactly the feed means. Feed is nothing but it is the advancement of the tool against the rotating workpiece. Okay. So likewise, whatever the kind of the cutting processes as we consider in that particular the category of the metal cutting process, so we may perform the rough cutting operation also, or we may perform the final cutting operation also. So taking into consideration how much amount of the material we want to remove, so according to that particular the dimensions, so we may perform first as a rough cutting operation, or we may perform if the small amount of the material which is we want to remove. So according to that, we may perform the this metal cutting operation. Okay. So I think my screen is right now it is visible to everyone. Yes.
The workpiece may be supported and driven by any one of these methods. Number 1, workpiece held between centers and tool driven by carriers and catch plates. 2, workpiece held on a mandrel, which is supported between centers and driven by carriers and catch plates. 3, workpiece is held and driven by chuck, with the other end supported on the tailstock center. And 4, workpiece is held and driven by a chuck, or a faceplate, or an angle plate.
सर माइक बंद करा इको येतो.
The methods of holding
Okay,
the work
okay.
may be classified under two headings. 1, workpiece held between centers. And 2, workpiece held by a chuck or any other fixtures. So today, in this video, we'll take a look at the different operations that are performed in a lathe machine. Do you know there are various types of lathe machines available that has their own required speed? The tool moves in a longitudinal direction to give the feed towards the headstock with proper depth of cut. The surface finish produced by this operation is very good. There are different turning operations can be done. They are straight turning. In this operation, the workpiece is held on the chuck and it is made to rotate about the axis, and the tool is fed parallel to the lathe axis. The straight turning produces a cylindrical surface by removing excess metal from the workpiece. Rough turning. It is the process of removal of excess material from the workpiece in minimum time by applying high rate feed and heavy depth of cut. Shoulder turning. When a workpiece has different diameters and is to be turned, the surface forming steps from one diameter to the other is called the
Okay, so just you have seen in that particular the video, what exactly there is again the n number of the operations which are shown in that particular video. But again, my concern is just whatever the different elements which are involved in the entire machining process, so that we must know. Okay, so as we rightly pointed out, whatever the geometry of the single point cutting tool which is to be there, so that plays an important role. Okay, so as we know, as again we have seen that particular the video, so it is an the process. Sorry for again an important call is there. So as we know, when we are considering the elements such as the cutting tool is there, then machine tool, what kind of the machine we are going to consider, what kind of the motion which is to be there, means we can call it as a cutting motion. Then feed, as we know, we can call it as a secondary motion also. It is speed motion, means cutting speed. As we know, the whatever the kind of the workpiece material which is rotate about its own axis. Okay, then feed is what it is, the advancement of the tool against the rotating workpiece. Then apart from that, the depth of cut is also defined here. Okay, so depth of cut means it is nothing but it is and the amount we want to remove in a one working stroke of the whatever the movement along with the required length. So that is what is we can call it as a depth of cut. These are all the definitions which are already discussed by sir. So just for the information, we must know what is mean by feed, what is mean by speed, feed, depth of cut, and what its importance in the entire machining process. Okay, then next point, just I want to discuss with you regarding the cutting tool classification is there. So as we know that there are the different categories of the cutting tools are there. So mainly it is categorized into the main two category. One we can consider as a single point cutting tool, and second it is we can consider as a multi-point cutting tools. Okay. So when we are considering the single point cutting tool, so there is only one cutting edge is there, and that is used to perform the cutting operation with the help of the single point cutting tool. So when we are considering the multi-point cutting tool, so it has more than one cutting edges which are there. Okay, and definitely the drilling operation and the milling operation uses the multiple cutting tool, which we can consider that which are having then more than one cutting edges which are there. So already this geometry of the single point cutting tool, you know, just I want to recap those points related to the this unit number 1. So as we know, this is the single point cutting tool. So where exactly the face, what exactly the cutting edge. Okay, so as it is shown, this is face is this particular the part which is tapered in the nature, and this particular is the cutting edge which is a single one in a single point cutting tool. Okay, and apart from that also nose radius is there, then flank is there, then again apart from that the different angles which are there, back rake angle is there, side rake angle is there, end cutting edge angle is there, clearance angle or the end relief angle is there, side relief angle is there, side cutting edge angle is there. Okay, side rake angle is also there. So this is what the single point cutting tool, as we know what exactly the kind of the difference is there between the single point cutting tool and the multi point cutting tool. So here is the second kind of the tool which is we are considering as a multi point cutting tool. Okay, so normally as we know, when we want to perform the milling operation, so large amount of the material which is we want to remove from the workpiece material, so we may perform this particular operation on the milling machine. Okay, so here whatever this particular the tool which is we are observing, these are the whatever the multiple cutting edges are there. We can use that particular, the name of the tool is a face milling cutter. Okay, so that part is already I think discussed by sir. So this is what exactly the difference which is to be there when we are considering the single point cutting tool and the multi point cutting tool. So again in the geometry, as we know, this is what is the we can say that the three-dimensional view. So in that top view is there, front view is there, and the side view is there. So in that particular present slide, so it will use us and the idea what exactly the position where we can call it as a, what exactly we can call it as a shank, then face, and all the other different kinds of the angles, so which are shown in the geometry of the single point cutting tool. Okay, so this is what exactly again the details about the nomenclature of the single point cutting tool, what we just discussed. Then one more point which is an important one when we are considering the single point cutting tool. Okay, so that is known as a tool signature. Okay, so in that tool signature, it will gives us an the idea about whatever the kinds of the different types of the angles along with the nose radius which is to be there. Now, if suppose you have given a typical tool signature like as you are observing on this particular the current slide 43 number. So it is mentioned that 0, 7, 6, 8, 15, 16 dash point 0.8. Okay. So what exactly means this particular the tool signature indicates? So again in that the sequence is there. So 0 it indicates the back reg angle. 7 it indicates the side reg angle is the 7 degree. Then 6 is shows the end relief angle. So likewise side relief angle 8 degree, end cutting edge 15 degree, side cutting edge angle 16 degree, and finally the seventh one and the last important element in the tool signature indicate the nose radius which is equal to 0.8 mm. Okay. So again, if we consider this particular the tool signature, so there are the 7 important elements are there. So out of that 6 are the different angle and one important 7th one is the nose radius. Okay. So again, I think this particular the portion which is already discussed with you. So just I want to recap those particular the review that particular the kind of the things. Then next one is, as we know, orthogonal and the oblique cutting process is there. So as already this particular the topic is also covered with the help of by considering the position of the whatever the tool which is to be there. So orthogonal cutting process and the oblique cutting process, which is shown here with the help of this simple diagram, and with the help of this diagram also you can show what exactly the kind of the difference which is to be there in between these two processes. So apart from that also, when normally we are considering this particular the orthogonal and the oblique cutting processes, definitely there is and some common points which are there. On the basis of that we can easily compare. So when we suppose consider in the orthogonal cutting process, cutting edge is perpendicular to the direction of the cut. So we can just check it here. So if we consider the orthogonal cutting process, this cutting tool is exactly what we can mention here. It is a perpendicular to the direction of the cut. Here, whatever the cutting edge and the direction of cutting which is not exactly perpendicular, it is having some inclination apart from that, whatever the 90 degree or perpendicular. Okay, so likewise, as we know, as sir already discussed with you also about this, what exactly the difference between the orthogonal and the oblique cutting processes. Okay, so taking into consideration what kind of the final shape we want to produce, so according to that we may use or we may recommend the orthogonal cutting process and or oblique cutting process. So taking into consideration, okay, so what kind of the normally the shape which is we want to produce on the final finished product. If suppose drilling is there, milling is there, shaping is there, operation we want to perform, so definitely we are going for the oblique cutting process. So when the operation like parting of operation is there, then turning operation is also there, then the sawing operation is there, so definitely we are going to perform the orthogonal cutting operation. Correct. So taking into consideration all these particular kind of the important processes, so we have to select an appropriate one, so that will serve our purpose. Okay, so this is what exactly the discussion which is there so far as the whatever the portion which is covered by the sir. Then apart from that also the machinability concept, as we earlier discussed, and the other kind of the processes which are there. So now today we are going to discuss more about chip formation process. Okay, what exactly happens when and how exactly the formation of the chip that is taking place. So as we know, when we are performing the machining operation, I am audible and screen is visible to everyone.
Yes, sir.
Okay, thank you, Sushant. Now, as we know, when we are considering this particular the different kinds of the elements, as we have seen in that particular the video clip also, and in the slide also. Okay, so we know that there are the different kinds of the elements are there, and while performing the machining operation, so there are the other kinds of the requirements are also there. Okay, so whenever we are performing the machining operation, that might be a finishing operation or that might be a semi-finishing process or operation. Okay, so as we know, normally our aim is to remove the unwanted material. Okay, and to provide the required shape. Okay, so what happen when we are going to perform the machining operation? So if the thickness of material, say round circular shape of the workpiece material is there, and its thickness is about 50 mm, and we want to remove that particular the diameter, sorry, not thickness, it is a diameter. So when we want to reduce that diameter from 50 mm into the 40 mm, okay, so almost 10 mm of the material we want to remove, correct? So for that particular case, one must know how much amount of the depth of the cut we are going to select for the first working stroke. Okay, so definitely fulfillment of the basic functional requirement for that particular case, we are going to perform the machining operation. Definitely it will provide and the improved surface finish and the better quality of the surface finish we are getting. So apart from that also, the machining is what normally the process in which the excess or the unwanted material, so that is removed from the that workpiece, or we can call it as a blank in the form of the chips. Okay, so apart from that also, whenever we are going to consider the different kinds of the tools, so we are in a position to provide the different kinds of the shapes. Okay, so normally the form of the machine chips is entirely depends on what kind of the work material which is to be there. If the hard material is there, then what is going to happen? If the brittle material is there, then what its effect? Then the softer material or the ductile material is there, what its effect on the formation of the chip. Okay, so this is the what we can consider. It is formation of the chip. It is mainly depends on these many parameters. So out of that, first one is the workpiece material is there. So in that we are going to consider whatever the material and the geometry of the single point cutting tool is also there in relation to the workpiece material. Then apart from that, whatever the cutting velocity, or we can call it as a speed is there, cutting speed, then feed is there, and also whatever the depth of cut which is to be there. Okay, then machining environment in which we can consider the whatever the kind of the environments, means speed, feed, depth of cut, then whether in that particular the machining process the cutting fluid which is using or not, and whether the cutting fluid, if suppose you are using, so that is an appropriate one with respect to the tool material and the workpiece material which is to be there. So whatever the cutting tool we are selecting, cutting fluid we are selecting, so it is having an means it's performing its functioning, means function like whatever the minimizing the friction between the tool cutting edge and the workpiece material. Also the temperature at that particular the zone, so it will be minimized. Okay, so these are so many kinds of the parameters which will contributes in the formation of the chip. Okay, so just again wait, I will show you one important video. So in that it will give us the entire idea about the formation of the chips. Okay, and then later on, once we know the formation of the chip is there by considering the basic mechanism, then after that we must know what are the different types of the chips which are normally formed. Okay, so please wait for the while so that I can again show you the important video about the chip formation process and the type of the chips are there. Okay, so please wait. I think my screen is visible to everyone. Yes. Okay. So please wait. Just I will show you.
Metal cutting, chip formation, cutting in microstructure. The basic process of machining is chip formation. Under practical conditions, such as here on a lathe, details of chip formation taking place at the actual point of impingement between workpiece and tool cannot be observed. With the help of a special experimental technique, the metal cutting operation can be prepared in such a way that microscopic observation and filming are possible. The cutting operation is performed as an orthogonal cutting at the definite optical plane of a quartz glass plate. It is thus possible to visualize the individual phases of material structure deformation in the area of the chip root and the processes in the zones of tool contact. As the following shot shows, while cutting, the wedge of a tool penetrates into the surface layer of a workpiece. It displaces the cutting material in the direction of work feed, causing it to run off as a chip across the face to the left. The ferritic-perlitic material structure has been rendered visible by polishing and etching. The frame width of these cinemicrographs represents about 0.4 millimeters. Flow chips. If the shear zone runs continuously without any fractures arising, the shearing process gives rise to a flow chip with a correspondingly consistent structure. Flow chips are formed while cutting ductile materials such as this carbon steel C45. As the ductility of a given material depends on the state of stress pertaining, small shearing fissures occur on the surface.
So as we know, when we are considering any kind of the machining process, as it is shown in this particular video, so whatever this the micro level analysis of the chip formation, it is not directly visible with the open eyes. Okay, so please observe this video clip carefully and how exactly the chip which is formed during the machining process, and what are the again the working conditions are there. So please observe this video clip very careful, because once you know that what are the different kinds of the parameters which are involved in the entire process of the chip formation, so definitely it is very helpful when we want to calculate the Mercer circle diagram for the force analysis purpose. And again, whatever the different kinds of the chips which are formed, as a continuous chip is there, continuous chip with the built-up A, or the segmental chip is there, or the discontinuous type of the chip which is to be there. Okay, so please observe carefully. So definitely it will help you for the better understanding.
Influence of the rake angle. The degree of deformation of cut material in the shear zone is governed entirely by the rake angle. A rake of 45 degrees results in a relatively slender, knife-like cutting wedge, which only causes small shearing deformations during chip formation. The flow chip is accordingly consistent in structure, with no distinctive deformations. The smooth upper surface of this chip, of about 120 μm thickness, is only occasionally interrupted by minute shearing fissures. On a surface with a rake of 0 degrees, the chip flow is diverted at right angles so that the compression and shearing processes produce a distinct deformation structure at the chip forming zone. The shearing fissures on the upper surface of the chip give rise to comma-like spikes and a correspondingly roughened appearance. At a negative rake angle of -20 degrees, the load on the cut material is exceptionally high. In addition to the primary shearing deformation, the friction on the chip surface together with the high compression stresses give rise to secondary shearing on the lower side of the chip. This results in a clearly delineated, bright flowing layer. The irregular shearing fissures on the upper surface give the chip a jagged appearance. Change to continuous chips. An insignificant increase in the thickness of the uncut chip under otherwise constant cutting conditions results in this material in a changeover to a continuous chip. In periodic sequence, individual elements of a continuous chip are formed by static friction and upsetting of the cut material on the one hand, and as a consequence of the increasing cutting force, by shearing and gliding on the other. A new upsetting and adhering phase, shearing and gliding phase, and again the transition to upsetting and adhesion, as well as shearing and gliding of the chip along the cut surface. A rounded edge represents an area of transition from face to flank in which the rake angle varies to negative values. In this area, the cut material is subject to high compression stresses, so that a flowing layer is formed at the cut surface. In the case of a scraping tool, that is, one with a very narrow uncut chip thickness, the chip is formed at the rounded edge directly in front of the flank in the region of greater negative rake. The cut material is compressed here and slides over the rounded edge as wedge-shaped parts of a continuous chip without touching the cutting surface again.
Okay, so this is what exactly we want to discuss with you regarding the how the formation of the chip that is taking place. Okay, so with the help of this video clip, so we are in a position to understand how the formation of the chip that is taking place by considering what kind of the nature of the workpiece material is there, what kind of the geometry of the cutting tool is having. So in the geometry, as we know, we consider the different kinds of the elements of the single point cutting tool. Apart from that also, as we know, we are going to consider the important point related to the cutting velocity, then feed and depth of cut, and also the important point is the cutting fluid, role of the cutting fluid. Okay, so this is what exactly the chip formation that is taking place. And as we know, in the same video it is mentioned that there are the different kinds of the chips are there. Okay, so in the next lecture we will try to discuss more about what are the type of the chips are formed, what its classification, and what are the factors which are actually responsible for the formation of such kind of the chips. Okay, so definitely once we understand the entire mechanism, so that will help to understand this mechanism of the cutting, and definitely it will help in context to the whatever the part which is to be we are learning in the upcoming lectures regarding the whatever that merchant four circle analysis and material removal rate. Okay, So please wait for a while so that I can mark your attendance, and then you can leave. Please wait. So any query or the any doubt which is to be there, whatever the topic which we discussed today. Omkar Salunke, any doubt or any query is there? I am audible?
Yes, sir.
Yes, sir. No doubts.
Yes. Ameya,
Yes, sir. No doubts.
Aditya Sawan, Siddhi Mahajan.
No, sir, no doubt.
Okay.
No,
So,
sir.
so if you have any doubt or the query is there, so you can put the message in the chat box also, or you can just ask me at any point of the point which is suppose is difficult to understand. Okay. So definitely we means we are I will show you some kind of the presentation to you, as well as some kind of the videos are also there. Okay, so definitely it will help for whatever actually we are learning in online mode. So if we use such kind of the different tools, so definitely it will helps for the learning effectively. If any suggestion or any kind of the input or the feedback which is supposed there, so you can share me on my WhatsApp number also, or during the lecture also. Okay, so thank you all. So we'll today's lecture we will stop here, and tomorrow I think we have a first lecture. Okay, so in the first lecture we will discuss about the whatever the rest of the part, what are the different types of the chips are there, and what kind of the conditions which are a result in the formation of the different types of the chips. Okay, so thank you all, and please inform to your other friends also, because whatever the number which just I am observing, it is about 33 students are there. Okay, and the strength is about, I think it is 75 from your A division. Yes, I am right.
Yes.
Yes, sir.
Oh, please inform to your friends also. So accordingly, whatever we are discussing here, so उन लोगों का डिस्कशन जो है या उनके जो डाउट है वो अभी मतलब नेक्स्ट इसमें ज्वाइन करेंगे तो उनको क्लियर नहीं होगा. ओके, so thank you all. Bye.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Bye. Thank you.
Thank you, sir.
Thank you.